In the last lecture, we talked about general functions and how graphing them can be problematic because you can only plot a finite number of ordered pairs points. You only in the solution set contains infinitely many points, and we usually only compute a finite number, maybe 5 by hand more with a computer, but it's still finite. What we want to do now is specialize and talk about particular types of functions. That's the first half of this course. So we're going to begin by looking at linear functions first. They're the building block functions. I mean, most functions you see are linear. They're very useful and so forth. We'll talk about this more. But linear functions are one of the specialized functions we're going to look at. So let's talk about it. We'll address this later, but an nth order polynomial function has this particular form. Okay? Nth order, so I write Pn. P stands for, I don't know, polynomial, N for nth order. And what they're going to look like is constants. These are called constants. Just keep the pattern going. Constant, constants, constants. And they're going to have powers. So if it's a fifth order, it'll be x to the fifth if that's the highest order, x to the fourth, x3, x2. Notice when you just write x is x to the 1, right? And when you write a0, it's a0 times 1x is 0. Right? So the powers, right? 5, 4, 3, 2, 1, 0. We've got it all figured out. So that's an nth order polynomial. So let's just begin here. Now we'll talk about general polynomials later. Let's just understand the game right now. Is that a polynomial? And the question is, I don't know. Is it or not? Take a guess and participate and try to answer. Is that a polynomial? Okay, let's take a look. Well, it's a polynomial if I can make it look like this form, right? That's the game we're playing. Again, I'm trying to emphasize the reasoning here. Well, see, I have to have all the powers. So there's no x to the first power, so I'm going to put in that constant, right? They're all constants, is 0. I mean, that's legal. So now I have x to the second power, x to the first power, and x to the 0 power, which is 1. So I had to first put it in the correct form. So if it can fit the template of a polynomial, it's a polynomial, no argument. So I can take a2 to be 3, a1 to be 0, a0 to be 2, and it is a polynomial because it fits the form. Right? So we're going to be talking about polynomials. That's a second order polynomial. How about that one? Pause the video, see if you can, is this a polynomial? Yes or no? Not a guess, you should know. Okay, let me jump in. It's the same idea again, right? Same idea. Can I put it in this form? Well, minus 3 is the constant, x to the fifth. Now I need 0 because I need an x to the 4, so 0 is the coefficient there, constant there. 0 in front of the x3, I have 2 on the others I can get. Right? So, again, does it fit the template? Yes. a5 is minus 3, a4 is 0, a3 is 0, and so forth. So because it fits the template, it is a polynomial by definition. Notice there's no guessing. Everything I'm doing in this class, right? It's precise, it's specific, it's clearly defined. We're not guessing. Sometimes it is, sometimes it isn't. That's not how it works. How about this one? Take a guess on that. Well, not a guess. Is it a polynomial or not? Pause the video, give it a shot. Can it fit the template? Yeah, it turns out that, yeah, constants are polynomials. They're 0th order polynomials, but they are in fact polynomials. F of x equals 3 is in fact a 0th order polynomial. So yeah, I mean, again, it's just a matter of using the definitions. All right, so we're good. Okay, now this is the argument. It turns out if a function is smooth, and you need some calculus ideas for that, but it's no big deal. We're not worried about that. Every function can be approximated by a polynomial around a point, around the next value. If functions are complicated, behavior-wise, go up and down and everything, then the polynomial that looks like them is going to be complicated. So instead of biting off more than we can chew, the idea here is let's start at the easiest case. Now you can say just picking A0 is the easiest case. It's too easy. There's nothing there. Okay, so let's do a little better than that. So we'll just pick the bottom two terms. And that'll be linear. I mean, this is it. We're going to pick the bottom two terms to start with. That's linear. Sorry, I hit the button by accident. And the next term we're going to look at after we finish linear is the next, quadratic. X squared quadratic. So we'll look at linear, then we'll look at quadratic, and then, well, there's no point looking at x3 cubic. It all gets bad from there. So then we're going to jump in and see what we can say about the general case. So that's the game plan for the coming lectures. We'll start out with linear, move to quadratic, and then consider the general case. Okay? So here it is, linear. Linear function has the form here. Right now, it looks like A1x, but you call it M. Okay, linear is L. I'm going to L for linear, right? I mean L for linear. And A1 is M, and A0 is B, so it fits the template. So that's the bottom part of our general polynomial function, right? This would just be a first order polynomial function. It's a line, linear function, okay? Fits the template. I can associate equation with that by substituting y equals L of x, and that is, of course, the line, right? That's the equation of a line. So it's a linear function and the equation of a line. Okay? Now here it is. We're going to graph this. Now again, pros and cons of what we were doing. For a general function, we have no way. We have to plot, in principle, every x, y ordered pair that make the equation associated with the function true, put them in a solution set, and then put them on a graph. But there are infinitely many, so we necessarily have to compromise. And you can say, well, that's no big deal, but it is. I mean, there are situations where you're actually doing math where that's actually, the point of interest is where something's happening. I don't want to guess, right? So the pro is, that's the general case. The con is we have to guess. We can't get all the points. So we're specializing. The negative here is, well, we're specializing. It's a linear function. But the pro is we can actually graph it. We're not guessing. Okay, so here's the idea. Again, here's the function. I just want to state it. I'm not saying you have to do it, but you should think. I have a rule and I have a set. The set is all real numbers, right? Again, I'm not saying you have to write it, but you should certainly have a process by which you're thinking. Everything we're doing is not mysticism, magic, it's math. Okay, I have a set, all real numbers. This rule works for all real numbers, right? You can substitute any real number into the rule and it works. In other words, I'm not dividing by 0, that doesn't work. I'm not taking square roots of negative numbers, that doesn't work, and so on. Okay, I have the rule, there's my rule, and it works for all those values, real numbers. Okay, and again, look at it. When you get a problem in general, I'm not going to necessarily tell you it's linear. Think about it. Is it linear? It is if you can put it in the right form, right? So if you can identify an M and a B, you're linear, right? By definition. Not my opinion, not because somebody told you so, because it is, all right? So that's the game plan. And we'll have quadratic functions, general polynomials, exponentials, logs, same thing, right? Yada, yada, yada. Same thing. Know what you're talking about. All right, so it's a line. I have M equals 2 and B equals 1. Good to go. What do? You have to convert it into an equation if you're going to graph it. So y equals f of x. Now again, I could call it L for linear. I mean, it's fine. Okay, so I have y equals 2x plus 1. Now I need a solution set. So in the past, we just plotted a lot of x values and got y values. But we want to do better. Fight smarter, not harder. Right? So first time through, we're just going to go and do it the old way. I'm going to pretend I don't know it's a line. And let's see. I get the y values. I get all my I get my 5 points. Again, there's infinitely many points in this solution set of ordered pairs. I only have 5. Now I'm going to graph it. So I'm just going to keep the solution set. I'm going to move everything over to fit everything in. Okay, and I have my points. And I draw them all out. And you can see it's a line. Right? It's a line. I mean, it's just great. I mean, no, I'm not complaining. It's fine. But is there a better way? Again, I don't want everything to be hard. Right? I mean, okay, when we do matrices, yes, okay, just we'll take our time. But okay, it shouldn't be. I want a better way. This is too much. I don't want to do too much. Too much work. Look, everything doesn't have to be a punishment. I am trying to take the pain out of this and have you focus on the ideas. Work with me. It's too much. I don't want to do that much. Let's try again. Okay, let's try again. So I see the problem again. I'm going to think about the function. Right, it has a rule and a set. I notice it's a line. I mean, right off, I notice it's a line. I notice it's quadratic. I notice it's a general polynomial. I know it's a logarithmic function. Right, whatever. I notice that. Take the time to do the preliminaries first. Right, my slope is 2. My m is 2. B is 1. Equation. Convert it into a line, equation of a line. Now again, here's the idea of the solution set. Fight smarter, not harder. Notice I picked x is 0. Why? Why do I pick x is 0? First of all, 2 points is all I need for a line. So I'm not going to go after 5 or 100 or 1,000. So if you're plotting a line with 10 points, 5 points, it's your own fault. You're wasting time. But notice, if I put in x is 0, look what comes out. Y is 1. Now that 1 keeps popping up, doesn't it? That 1 is over here. That 1 goes in the solution set, 0, 1. That's my b, though, right? The 1 is my b. It pops up for free. So let's just look at the graph. That 1 there, right, y equals mx plus b, b is 1, gives me my xy 0, 1, goes in the solution set right there on the graph. I mean, I don't even have to work. I look at it, b is 1, there's a point right there. Right there. I mean, I don't have to write out the solution set. I don't have to, whatever. It's called the y-intercept. I wonder why it's called the y-intercept. I don't know. Again, should the terminology help you? I know you think it's all an exercise in pain. It's not. It's not. It's called the y-intercept because I'm thinking it intercepts the y-axis. What else would you call it? Plant, bill, cat? I mean, you got to give it a name that makes sense. Y-intercept. Right? And all you have to do to plot that 1 point, and I only need 2, and I have 1 for free. Right? It comes right from the y-intercept. You don't even have to work for it. Right? The point is the y-intercept. The y-intercept is the point. The point is a back and forth. Now, the question is, where do I get a second point? Where do I get a second point? Well, don't work hard. As far as I know, these things have to, I don't know where B actually comes from. M, I think, comes from monte. I don't know how to say it. It's French. It means climbing. It means slope. English translation, right? There's a slope, a grade. I mean, you know, okay, that's where it comes from. M is slope. Rise over run. Rise over run. We have 2, right? 2 is 2 over 1. So what does this say? I go down to my point. Right, I go down to my point, go up 1, go up 2, right? And then I'm going to run 1, so I go over here and go over 1. That's it. You should never work harder. I don't care about formulas. y2 minus y1 x2 over, it's not meant to be done that way. If you can't just do it quickly and efficient, now I know some of the homework doesn't do it, it's not my fault. I didn't write the book. I'm not interested. Right? If you can't just do it by hand like I did here, it's not worth doing. Plot it on a computer, right? I mean, it's not 1812. Okay, so just plot your 2 points. Your intercept, your y-intercept is free. Your slope, just up and over. You have your second point, right? You have your second point there. If you want, you can put it in your solution set. And then you draw your line and you're done. That's it. And that's too much work. I mean, it's still too much work for me. And it should be for you. Now let's look at it again. There it is. Let's start again. I just see it's a line. I have m is 2, b is 1. There. I mean, you should be able to just do this. And there's some examples in homework. It shouldn't take you more than 30 seconds, 15 seconds. There's my b, right? X is 0, b is 1. There's my slope, get my second point. Bam, there's your line and you're done. I mean, seriously, if you don't have to work hard, don't. I mean, I'm telling you, I don't see why this has to be so painful. Okay, later some things, but I will do the best to minimize. All right, 2 points, done. It's a good question. You say, what else can I do with lines? It's a good question. You can do piecewise. See, lines are versatile. Very, very versatile. Okay, piecewise. What does it mean? Piecewise, linear functions. Bam. Yeah, that just happened. Yeah. Mind blown, right? Yeah, okay, let's see. This is a big deal because lines are easy to work with and piecewise linear functions are wonderful. Here it is. Now don't be intimidated. Calm down. Just get a deep breath. Calm down. Let's just look at it. It's actually, I don't think it's as bad as it seems. It's just shorthand notation. X is less than minus 2. So what goes in the box here has to be less than minus 2. Right? Look at the number line. X less than minus 2. Right? Again, I'm not taking the minus 2. Right? Less than. Right? So I'm not including, it's a circle. You don't have to draw this, but I'm just pointing it out. And I want x less than, so I went over here, right? I want this side of the world, all right? So this says f of x equals x plus 1. So f of x equals x plus 1 over here. I mean, it's really just about understanding what we're talking about, okay? That's where it comes from. Now let's look at this piece. Minus 2, x has to be between minus 2, including minus 2 and 3. Notice I'm going from minus 2, I'm including a minus 2 to 3, right? I'm including less than or equal to, so I get the solid dot. You don't have to draw the picture, I'm just trying to explain it, right there. So on this piece, that's the rule, f of x equals 5. I mean, it doesn't have to be complicated, right? It's, again, think of it, the different pieces, x less than minus 2 to 3, greater than 3, they're the different students in the class. There's a different final grade for every student. There's a different rule for every single student in the class, right? Final grade. All right, and that's all we're really doing here. For the people in the left, in the middle, and on the right, they're different rules. When x is greater than 3, I'm over on this piece, and again, I'm going out greater than 3. I'm not including 3. On this piece, right, x greater than 3, this is my rule. So this rule, right, applies over here. So again, just think of it as 3 different groups. It's still one function, right? Like we talked about the grades in the section, right? It's still a function. There's just 3 different rules, right? One rule applies to these people, one rule applies to those people, and so forth. Now let's try to compute a few things with this rule. Okay, I mean, just go through it. So let's look at the first one. Minus 5, minus 3, 0, and 4. We're going to plug in. Okay, let's start here. How do I do this? Well, minus 5 is x, right? I mean, minus 5 is x. X is minus 5, right? Because what's in the box, right, goes for x. X is what's in the box. X is the box. So minus 5 goes in the box. So am I here? It's minus 5. Do I fit in this? Am I in this group, or the top group? That's the question. I mean, what group are we in? Right? Our point, that's the interval, right? That says that only applies for x greater than 3. Our number is minus 5. We're not in there, right? We have minus 5. So is it in there? No, it's not, right? So cross that out. It doesn't go in there. Right? So we just cross that one out. Just cross it out. I mean, I don't care anymore. How about this one? -2, including -2 to 3. Right? That's that interval. Look down here, -2 to 3, right? So the question is -5 in that interval? No. Two strikes. No, it's not. I mean, really, that's it. It's just understanding it. Okay, well, I'm guessing the last one's got to work. Okay, I'm just guessing. So here's my interval down here, less than -2, right? -5, bam. Yes, it's in there. So that's the rule that applies here, right? -5 belongs to that group, so I'm going to use that rule, right? So there's my rule. And -5 goes in the x for the x box, plus 1 is -4. And that's it. See if you can do the next ones. I'll do it, but pause the video, give it a try. This is the kind of question you're going to have to do. See if you can do it. Okay, let me jump in. -3. So x is -3, right? Because my x is a box. -3 is in that box. Right, so x is -3. In other words, the box is holding the number -3. All right, we just have to figure out the interval. Are we in this one? Again, here's the interval represented on the number line. All right, x greater. Our point is -3. And is that in the interval? Right, -3. So is -3 in the interval? No, so I just crossed that one off. I just cross it off. Look at the next group. Or do we belong to the next group? So here's our -3. Here's my interval, right? There's my interval. Do I belong? Again, you may not need the picture. You can do this in your head, right? But I'm just trying to show you graphically. No, it doesn't fit. So we cross that one off. Just cross it off. So how about it? Has to be, right? If it doesn't fit the other two. Has to be. Right, so -3 is there. That's my interval. And I'm thinking something could blow up here. Something's going to happen. Nope, it worked. It worked fine. Right, it worked fine. So that's my rule on this interval. Right, and I just plug in. I just put a -3 in that box, and I'm done. Okay, try the other two if you haven't. Pause. I'll just continue in time. So how about 0? X is 0. 0 is in the box. X is the box. Does it fit in that box? Of course. Oh, it doesn't. Oh, yeah, because it's -2. See, I was getting sloppy. How about this one? Is X in this box? Yeah, that one works, right? So it says that the rule is for all X in that box, everything equals 5. So, I mean, that's what it says. It's 5. I mean, it's an easy rule. Anything that goes in for X comes out 5. Everyone in the class got an A. Everyone's favorite color is blue. Everything's a constant. It's fine. It's the easiest one. How about F4? Try it again if you haven't. Find the interval where it works. It works here. You see, you can do this pretty quick after a while, right? So that's my rule. So I just plug in wherever there's an X. That's the box. I plug in a 4, and I'm done. Okay? So, yeah, this is, you can get the numbers down. Okay, now here's, we're going to crank this up a little more. Graph this function. Now, this is a little tricky, so let's go through this. Now, okay, what's my function? I'm just writing it all out. I wouldn't bother with it, but it is. It has a set and a rule. The name of the function is f. That's the rule. The rule has 3 parts, but it's still one rule. Right? It has a top, middle, and bottom part, right? Different people. There's a different rule for the 3 different people. And it works for all real numbers, right? You can see any choice of x, and you can get a rule. What are the equations? Well, we're going to have pieces. If x is a number less than -2, right? This piece, we're on this branch, then that's my function, right? That's my function rule. So that's my line on that piece. Right? Remember when we did that before and we had it not defined when x was 1. It's the same thing here. This rule and that line, those xy pairs are only valid as long as x is less than -2. right? As long as x is less than minus 2, the xy pairs here are valid. If we take an x, right, xy pairs, these are the x's. If the x is between minus 2 and 3, if we're in this group, f of x equals 5, so our y value is y equals f of x 5. Right? For those x, this is how I get the y values. And on the third one, if x is a number greater than 3, right, what goes in this box is greater than 3, then this is how I get my y value. Right? Okay, so what I have now is 3 basically lines. Now, you could just go ahead and plot points, right? Using this rule, I get minus 2. Right? So that goes in my solution set. For minus 2, I have to use the right rule, right? Actually, that's wrong, right? The minus 2 should be 5. That's wrong. I got a bad number there. That should be 5. Right? That should be 5. You'll see that should be a 5. So I applied the wrong one. Okay, minus 1. I got the right one here between minus 2 and 3, right? I get the y value then has to be 5. Right? So I get this point. And so forth. I get all the points. Now this is the problem. I mean, we've done everything faithfully. I think we're fine. And then you graph it. This is your solution set. Here's your graph. You plot your points. I mean, it seems to make perfect sense, except it's completely wrong. Aside from the fact that I got 1 point wrong, it doesn't really affect anything. Why is it wrong? We didn't plot, right? We didn't plot enough points. Again, remember, if you're plotting points, you know you get the answer if you get infinitely many points in your solution set. We only picked, whatever, 6, 7, I think. And one of them was even wrong. But it doesn't matter. You're never going to get it that way. So what do? It's actually not that bad. Okay, let's try again. So this is what I had before. I just have 3 different xy pairs, right? This is how I'm generating the xy pairs. This says if x is a number less than minus 2, right? It's a caveat. It's a caveat. Remember, I'm getting xy pairs. The y values come from that part of the function rule. If I'm between minus 2 and 3, including the ends, the y values come from there, and same at the top. Right? Remember, what I'm doing is xy pairs. Right? Xy pairs. All right. Well, let's start here. This is pretty straightforward. Make sure you can do it. If you're not, can't, talk to me about it. All right? So as long as x is less than minus 2, I've used this. Slope 1, intercept 1. We can graph that. Right? There's my intercept. Go up 1, over 1. There's my second point, and I draw it. Now you should be able to do this really quickly. Right? You should be able to do this really quickly. So that's it, from here to there. Now remember, back in that other example where we had x not equal 1, right? 1 was not in the domain. We had to make sure we take that out of the solution set. Right? The solution set is only valid for the valid x choices. Right? So we have the line, but our valid x choices here, we can only accept x values as long as they're less than minus 2. Don't panic. We just draw the line. It's easy. Minus 2 is from, well, minus 2 over this way, right? This is where we can accept x values. So what do? Just cut off what you don't want. I mean, keep the part you want. Draw your line. The line is xy values, assuming x is all real numbers. It's not. So just crop it. Just crop it and take the ones you want. And that's it. For x less than minus 2, that's the part of the line I keep. That's how I get the xy values. Right? Remember, it's a solution set. I need x and y values. Right? So from minus 2 all the way over, and that's those are the y. That's how I get the xy. Remember, everything on the red line has an xy value. Those xy values go in the solution set, they make that equation true. And notice I don't include the 0. I mean, I have a hole there because it's x less than minus 2. So that's good. Now here we go. Why don't you try this piece yourself? Again, if you mess up, I'll do it. Give it a shot. If you mess up, you'll learn something. So try your hand at this. Pause the video, and then I'll kick in. Okay, let's try it. That's a line. Slope 0, intercept 5. Right? Slope 0, intercept 5. Right? You have to put it in the right template, right form. That's why I went over that stuff. Everything, if it's a line, you have to have an M and a B, right? MX plus B. You have to have it in the right template. Right? So M in this case was 0. So the B equals 5, bam, that's my point, slope 0, there it is. Slope, get a second point, yeah, okay. Draw your line. There it is, it's my line. But again, this line is only valid between minus 2 and 3. So again, you should be able to draw a line pretty quickly, right? Now I just have to truncate, just crop it, right? Minus 2 to 3. That's the region I'm talking about. If it's not in that region, cut it off. Notice I include the minus 2, the endpoint minus 2, and I include the 3 because it's included in the interval. X is greater than or equal to minus 2 and less than or equal to minus 3. So I am including x equals minus 2 and x equals 3. So throw out the parts you don't want and you're good. So I've got two pieces. Okay? How about the third one then? See, it's between minus 2, including the minus 2, and 3, including the 3. Right, so that's it. So why don't you guys try again this last one? You should be able to draw the line quickly, right? Try to draw the line quickly. Okay, I'm going to jump in. So as long as x is a number greater than 3, I get the y value from here, from this equation. Slope is 2. B is minus 3. I just go. B is minus 3. I just plotted. Looks like I missed a little bit down here. Slope is 2. Go up 1. Go up 2 over 1. I get my 2 points. I draw the line. Right, that's my line. Here, there it is. But notice this line is all these y values, not the line. The y values are only valid as long as x is greater than 3. So go over here. X has to be greater than 3, so we want this area, right? This region over here, right? We want to be greater than 3. So this is where we keep it, and we truncate it, throw it away everywhere else. So I throw everything else away and just keep from here over. Notice it's x is greater than 3, right? Greater than 3, so I have the whole. And that's it. Again, I mean, if you're struggling with this, let me know. You should be comfortable with this. Okay? It takes a little getting used to, but just follow the steps and hopefully you'll be fine. If not, just let me know. This is something you can do. So again, when you just plotted the points, even though I made a hash of it, you're not going to get the right answer. You have these jumps and these breaks. You just can't plot enough. I mean, if you could plot infinitely many, of course. So that's the difficulty. This is, again, there's ambiguity. This is how we work around that. Good question. Anything else we can do? Well, what can you say about a line? I mean, you can do parallel lines. What makes a line parallel? What is the characteristic? Well, lines, you only have two things. You have a slope and an intercept. So parallel lines won't have the same intercept, so they have to have the same slope. And then, of course, you can do perpendicular lines, right? This is the orthogonality relationship, or negative reciprocal for slopes, whatever. It's no big deal. I'm not trying to make this harder. Negative reciprocals. Let's do an example. Write an equation of a line parallel to the graph of the line specified by this equation and containing the point. It gives you a headache. Okay, let's look at it. The problem is that a line? How would you know that? I mean, this is the kind of thing that makes you mad. I mean, I get it. I understand your frustration. It's not a line. It's not certainly in the right form. You have to put this in the correct form is the problem. So I'll move the x to the one side, right? Divide by 4 everywhere, multiply by 1/4 and clean it up. So I have to do some preliminary work just to make this, to know it's a line, right? I mean, it's very misleading. The slope here is not, I don't know, -1, 4. I get all sorts of crazy things on tests for people who don't study. If it doesn't look like y equals mx plus b, you don't know it's a line. And that's why this question is somewhat misleading, right? An equation of a line parallel to the graph of the line specified by. It's misleading. That they did not give you it in the form of a line. You have to do that first. But now we're good to go, right? We have a slope and we have the y-intercept, so we're good. I think, again, what we did with the first lecture, graphing things is a big help. Like I said, you can often know your answers are correct. You should be able to graph a line in seconds. So here's my y-intercept, x is 0, b is 4. Slope, right, 1/4, go up 1, right, go up 1, right, 4 over, 1, 2, 3, 4. There's my second point. Graph the line. Of course, the points come before the line, but I'm just saying. That's my line, right? That's my line. Now I want a line parallel to this line, to the red line. See, the issue is there's lots of parallel lines, right? Which one do we want? I mean, that's the question, right? Look at the problem. What is going to specify fix our line? Look at the question. Look at the question. What in this question is going to specify which of these lines we choose? You can pause a second. Give it a shot. That. We want the line that goes through this point. See, there were lots of choices for line. We picked the line that goes through this point. And it'll work itself out. So let's do it. But you see, we have a good idea what the answer looks like. And see, this is what I'm saying about checking your answer. Right? The actual y-intercept is somewhere around 3.5, minus 3.5. So if I make an algebra mistake, and I did actually when I was typing it up, I got 11. I knew it was wrong by looking at the picture, right? It has to be wrong. You'll see where I think it's this one where I made a mistake. So again, drawing this picture should take seconds, and it's a way of checking your answer. Again, how much are those points worth to you? So here's parallel. Parallel. It's a line, right? We're going to work it out on this side of the paper here. Let's just put it right here. It's a line. Y equals M. Look, I don't want point slope. They don't save you. Look, I'm sorry people made you memorize that. People had too much time on their hands. People were, vindictive. I don't know why. Line is y equals mx plus b. There's no advantage to doing point slope. None. None whatsoever. I have my slope, right? Do I have a slope? Sure I do, right? They're parallel. The lines are parallel. So the slopes are the same, right? That's what it means to be parallel. So I do have the slope. I just plug it in for m, right? Plug it in. How do I get the intercept, right? I need a slope and an intercept. Again, what do? I take the point. That's what we did for the picture, right? Just plug it in. Plug it in and solve for b. X is 2, right? Y is minus 3. Make sure you put the x in the x and the y in the y. And we'll solve for b. And you can always do this. Okay, clean it up. 1/4 times 2 is a half. Bring it to the other side. This is where you can make algebra. Now, I didn't mess up on this one. I messed up on the other. But this is where you can make algebra mistakes. This minus 7/2, minus 3.5, whatever. Potato, potato. Just plug it back into your line, and you're done. Notice I wrote plus minus 3.5 because I'm just emphasizing it's the y-intercept. It's minus 3.5 in the picture. So notice my given line goes through what? The 0, 4. Right? The first line we were given goes to a point, right? It has a slope of 1/4, but it goes through that point, 0, 4, the y-intercept. Notice my second line has a slope of 1/4, right? It goes through that point, but notice the intercept is minus 3.5, which is what we emphasized before. That's just kind of why I wrote it down, minus 3.5, just to emphasize it's what we got before. That's fine. Okay, let's do the same thing, only perpendicular. It's going to be almost exactly the same problem. Pause the video, try it. It should be, again, I don't want you to reinvent the wheel. I'm not asking you to invent relativity or come up with the next generation dimension, right? Just do what we did before. Do exactly the same things we did before, only fix it for perpendicular and you see it works the same way. So give it a pause and give it a try. Okay, here we go. Right, solution. It's not in the right form. So if I just see this in the beginning, we did it already, but I do exactly the same steps to convert it to the right form. So I have a slope and I have a y-intercept, right? And I draw the picture. So the red line is the picture, right? We did that from last time. And notice there's a lot of perpendicular lines here. A lot of them. Right? So the question is, which one do I want, right? I mean, there's a lot of them. How do you pick? How do you pick the line that's appropriate, right? That's what we're talking about. Well, here's the problem. What here helps? The point. We want to fix the one that goes through this point, the particular perpendicular line that goes through this point. And notice, this gives me a pretty good indication of what the y-intercept is, right? It's about 5, I'm guessing. I mean, it's between 4 and 6, right? It's about 5, my graph, you know. So I have an idea of the answer. Understand what I'm saying. You can check your answers. So perpendicular line. We're going to work it out over here, right? Work it out over here. It's a line, y equals mx plus b. Do you have a slope? Sure you do. If you have the slope to this line, we're perpendicular, right? We're perpendicular, so it's the negative reciprocal. Flip it over and put a minus sign in front of it. I mean, don't make it hard. Just plug that in for the slope. Now, how do we calculate b? Well, we need information from here. What do we take? What did we do last time? We took the xy value there, that point, plugged it in, and that gives us b. So I plug in x is 2, y is minus 3, and I solve for b. Now see, this is what I did. I messed up. See, and this is common. This is why I think the picture is important. Now again, I'm not necessarily paying that much attention when I read it, but minus 3, I did minus 3 minus 8, and I got minus 11. And when I looked at the picture, I knew it was wrong. But that's the kind of mistake you make. It's not like I said, it's not like you're dumb. You're taking a test, you overlook something, and it's not going to cost you 10 points, but it is going to cost you a point or two. I mean, they add up. So see, it's actually 5. I put in minus 3 minus 8 is wrong. So go back and plug it into your line, and there's your equation of your line. And again, notice we did get 5. Right, so the slope is a quarter. There's my first one. Notice it goes through the point 0,4. That's the y-intercept. Right, that's the line we were given. Here's my new line. Notice it goes through the point they gave us, 2 minus 3, but its y-intercept is 5. So there's that line. And again, it's a good way of checking. It's a good way to check your work. It's a good way. You should be able to draw a line quickly. So this is it. So what should you get out of this? You should be able to graph a linear function or equation of a line by simply doing 2 points quickly. I don't need formulas. I don't need gimmicks. Plot the y-intercept, rise over run, get a second point, bam, you're done. You should be able to do that and do it quickly. You should be able to graph piecewise linear functions. Now, they're a little more complicated. You usually have to draw a couple of lines and so forth and so on. But, I mean, you should be able to do that. If you're struggling with it, just let me know, okay? You should also be able to find the equation of a line parallel to a given line. That's like the examples we just did, and perpendicular. So those are the expectations. That's what I expect you to be able to do. That's what's testable, okay, guys? So keep up. Make sure you're comfortable with this stuff. All right, well, good luck with the problems, and let me know if there are any issues.